Okay, so here's another question. The conic section is centered at -1, -1, and it has one vertex at -3, -1. The distance between the directrix and the vertex is 3e/8, where e is its eccentricity. Given that e is a multiple of 2, find e, and then secondly find the conic section equation, of course. So the first thing I do is to visualize this thing. So what do I have? Okay, so I have a conic with the center given -1, -1. So it's somewhere here. And then the vertex, one vertex has been given. It's -3, -1. So this is the vertex, so meaning that, okay, so because we are told that e is a multiple of 2, so obviously e is greater than 1. So I'll put something like that. But I'm assuming that it's a hyperbole. But if e is a multiple of 2, then it makes sense that it is. Okay, so now, what else are we given? So here, just from this information so far, we've seen that this distance in between here is a. And so what is a? A is -1 minus -3, which is going to be 2. Now it is going to be 2. That's the distance between -1 and -3. So a is 2. Okay, so if you want a squared, what is a squared? A squared is 4. Oh, just finding it. You just move it somewhere. And then we also thought that the distance between the directrix and the vertex is 3e/8. Now, what is the equation of the distance between the directrix and the vertex? Remember, in the other one, we said the distance from V to G, the directrix, is given by A minus A/E. Now, it has been given as what? As 3e/8. But don't we know what A is? We have found the value of A here. It's 2. So now we have 2 minus 2/E is equal to 3e/8. If we multiply throughout by 8e, we'll have 16e minus 16 is equal to 3e squared. So when we arrange this, it's going to be 3e squared minus 16e plus 16 is equal to 0. So then we can, this is a quadratic. This product is 3 by 16, that is 48. So you can think of two numbers that when you add, you get -16. When you multiply, you get 48. That is -12 and -4. So we'll write this as 3e squared minus 12e minus 4e plus 16 is equal to 0. So then 3e, so we'll have e minus 4 minus 4, e minus 4 is 0. So this is giving us e is equal to 4, or e is equal to 4/3. But remember, we're told that e must be what? A multiple of 2. So that statement is helping us to pick which e. So depending on, I mean, you could have the 4/3 as your E, but except that it's not a mod of 2. So pick, therefore, E to be equal to 4, which is a mod of 2. And then the second thing is we're asked to find the equation of the conic section. How do you find the equation of the conic section? So you have E and you have A. So we know that E is equal to, what's the formula for E? C over A. So if E is equal to C over A, and we have E, we also have A. So we have E to be 4, A to be 2, so it is equal to C, meaning that C squared is equal to 8. And so when I mean, C is equal to 8, so C squared is 8 squared, which is 64. And then we want to get the value of B. So we have B squared is equal to 64 minus 4, which is equal to 60. And so then we can have the equation. Okay. So it's along the x-axis. So the center has been given as -1, -1. So what we have here is x plus 1 squared over A, that is 4, minus y plus 1 as well, squared over this. This is equal to 1. That's the equation. So if you just want to visit it out, let me write it again. So I use already. So I'm saying the equation is going to be x plus 1 squared over a squared is equal minus y plus 1 squared over 60 is equal to 1. And 1 is equal to 1. Okay. So that's how you answer such questions. So you need to be careful when this type of questions come. Please, the issue of being given the distance between the directrix and the vertex. Immediately you see that distance, remember this formula. Once you get that formula, then it will be easy for you to move forward. This formula will also remind you that, oh, suppose the information I have is not sufficient enough. If I also need to know the distance between the directrix and the center, then it means it's A over E. That's why we're subtracting from the whole A. So it's the main distance. So here I will assume that, oh, so I'm having the directrix somewhere here. Okay, so the distance from the vertex to the directrix is what we are calling A minus A over E. This simply means this distance here that remains is A over E. So you always keep that in mind. Then there will be no issues. Or in any assessment. Hope you find this interesting.